In this video, I want to use Mathematica to investigate 4 questions about increasing decreasing functions, left and right Riemann sums, and over and under estimates for the integral. This is stuff that we looked at in Lab 2, and I have these 4 questions that you might be able to answer from what you remember about Lab 2. I would like you to stop the video and attempt to answer these 4 questions, and then after you answer them on writing in your notes, start the video again and see if your answers are correct. So hopefully you've done that. Question 1 concerns increasing functions and left Riemann sums. So what I want to do is I want to start by letting f of x be one of my favorite increasing functions, which is the exponential function, e to the x. We will let a be equal to 0, and we will let b be equal to, I don't know, let's make it 5. Now, this particular notebook has the same initialization cells that Lab 2 had, so left rex draws a picture of a left Riemann sum with the appropriate number of rectangles. So this is the picture for a left Riemann sum with 5 left rectangles. And clearly this is an underestimate since the rectangles are completely underneath this increasing function. There's nothing special about the number of rectangles. If I squish a lot more rectangles in there, I still have an underestimate, because the rectangles are still completely underneath the curve and hence they're missing pieces of area. There's also nothing special about the increasing function that I happen to choose. Another increasing function is the arctangent of x. And arctangent of x is increasing on, let's make this interval going from 0 to 10. And if I look at 20 rectangles for this one, this is the picture. And again, the rectangles are completely underneath the curve, and so the left rectangle estimate has to be an underestimate. That's the main idea that I want to grasp in this first question. So I kind of want to synopsize that. If I have a function that is increasing on the interval between a and, let's see, I want a is less than x is less than or equal to b, then any left Riemann sum will underestimate the integral. And that's the main thing that I want to grasp from that first kind of set of stuff. Our second question deals with the function is still increasing, but we want to look at right Riemann sums. So I'm just going to kind of go back and grab this cell and put it here, and we will now start with a right rectangles for the arctangent. And let's start with 20 of them. Well, here's the right rectangle estimate, and what I noticed here is that all of the rectangles are above the curve. The curve is completely underneath the rectangles, so the right rectangle estimate must be an overestimate. There's nothing special about the number of rectangles nor what increasing function we look at. Another increasing function would be the natural log, and it's increasing on 1 to 10. And if I look at right rectangles for that function, again you'll notice that the right rectangles go over the function consistently, and so we have an overestimate. So what I want to do is I want to synopsize what we have here. And if f is increasing on my integral, then any right Riemann sum will overestimate the integral. Well, what happens if I look at decreasing functions? Well, let's see. Let's look at a decreasing function. One of my favorite decreasing functions is e to the minus x. And let's make a equal to 0, and let's make b equal to 3. And let's look at the left Riemann sum for this function. And let's start off with 5 rectangles. So here what I want to notice is that the left rectangles are now overlapping the function because the function is decreasing. Again, there's nothing special about the number of rectangles. If I squish a whole lot more in, they're still overlapping my decreasing function, so my left Riemann sum estimate is still an overestimate for the integral. There's nothing special, again, about this particular decreasing function. Another decreasing function would be cosine of x on the interval between 0 and pi over 2. And if I look at that left rectangle estimate, you'll see that the left rectangles are overlapping the curve, and hence the left Riemann sum is going to be an overestimate. And so let's grab my text cell, and I will copy and paste it and edit it. So what we've seen for functions that are decreasing, if I look at any left Riemann sum, I will get an overestimate because that's what we're looking at right here. Well, we finally need to look at decreasing functions, but right Riemann sums. So let's grab our decreasing function and look at a right Riemann sum. And let's chop the number of rectangles down a little bit. Here, the right rectangles are now underneath the curve because the curve is decreasing, and so the right rectangle estimate is going to be an underestimate. Again, there's nothing special about the decreasing function. Let's see, another nice decreasing function would be 16 minus x squared is decreasing on 0 to 4. So let's look at the right rectangles for that particular thing. Here's the function, and you'll notice that the right rectangles are all underneath the curve, and so the right rectangle estimate is clearly going to be an underestimate. More rectangles doesn't change the fact that we are missing area because the rectangles are underneath the curve. And as a consequence, what we can say is that if f is decreasing on an interval, then any right Riemann sum will underestimate the integral. And the basic thing that I want you to do is I want you to think in terms of this. So my basic advice on trying to figure out whether or not you've got an overestimate or an underestimate is to draw the picture. If we have an increasing function and we are looking at right rectangles, they will overlap the curve. So f is increasing right rectangles, overestimate the integral, and left rectangles will underestimate the area, and there should have been a dx up there as well, so I'll put that back in. But if I am on a decreasing function, so my function looks like this, and I draw some rectangles, if I draw right rectangles, the right rectangles are going to be underneath the curve. So if f is decreasing, the right rectangles underestimate the integral. And when I draw the left rectangles, they are going to overestimate the area. And that is how I can easily figure out questions that are asking me whether or not something is overestimating or underestimating the area.